Hey, we're ready to go. Okay, thanks for attending. This is about Project Jigsaw. I am not Mark Reinhold, as you might well be aware. I'm Paul Sandoz. I work for Oracle. Mark unfortunately can't make it, so I am replacing Mark. Mark is not replaceable, by the way. I'm speaking instead of Mark about Project Jigsaw and what Project Jigsaw is about. So let's get rid of the safe harbor statement thing. I will be talking about stuff that's in the future. So this is actually relevant. Agenda. So I'm going to talk about the modular platform and what Project Jigsaw is. And talk a bit about its status. And then I'm going to get into demonstrations. And that's going to constitute the majority of the talk, I hope. And this is, I'm going to show lots of stuff. I'm going to try and show it in a form of coherent order, but I've got a concurrent algorithm running in my head, so there's going to be a bit of outer order execution going on this. So hopefully it will all come together reasonably well. So the goal is, if I'm successful, is to give you a comprehensive overview of where Project Jigsaw is today and where it's heading in the future, essentially its current status. So what about a Java platform module system? There's really 4 goals on a module system that we're designing for Java. You can see these goals represented in the link below. I'll send the slides out later, Project Jigsaw goals and requirements for these, which goes into more detail if you're interested in reading more about these. But the first one is scalable. At the moment, the JDK, or the JRE, depending on what you use, is quite fat. There's a lot of stuff in there that you might not want to use, especially if you're running on systems like a Raspberry Pi, and that we should be able to sort of scale it down and scale it up as you require based on the platforms and what you actually need. For example, how many people use Corba today? Wow, nobody. It's tumbleweeds. No one uses Corba, but it's in the JDK. Maybe you don't have to have it in the JDK if you don't want it there, so it'll become a module. There's also the scalability of when you're building on top of the JDK, building your own modules and stuff like that. There's scalability in your systems. Having a module system that helps you define relationships and dependencies can help you build better, larger systems too. The other area is performance. There is going to be a new phase introduced in the development lifecycle of Java, and that's a linker. And when you've got a linker, you can transform code into other code, and that becomes interesting for lots of optimization opportunities. For example, we could remove dead code statically. If we give it a bunch of jar files and the modules we depend on, we can sort of analyze this and say, oh, we don't need this, this is not necessary. Obviously, if you're using reflection, the optimizations are limited, but there's potential to have another stage in the process, a linking stage, where we can do lots of interesting optimizations. Another one, say, we could actually inline lambda calls, for example. Perhaps that's one interesting one. Or we could pre-verify classes and so forth like this. There's lots of potential for all sorts of interesting stuff, performance-wise, in a linking stage. Also, we are looking at alternative representations for rt.jar, which I'll talk about later. We can have an alternative way of representing that information. That means we may be able to look up classes faster. We may be able to represent them slightly differently. So there's lots of opportunities here going forward for performance of the system. We also want to make this more secure. And I like dividing security into 2 types of things. One is the security manager, push that to the side, and one is the integrity of the system, push that to the other side. How many of you run Java with a security manager? 1, 2, 3, 4 people? 5, 6? Wow. That's not a lot, actually. I expect a little bit more, but I think that suggests the security manager is mostly used in the types of environments that are more legacy, in my opinion, like applets and so forth like this. There are cases where it can become an advantage to use it on the server side too, but I think it's useful to divide the concepts of the security manager side and the integrity of the platform side. So Jigsaw will introduce boundaries between modules so that classes that are in a module that are not exported are actually private to that module. It's a bit like a private field of a class being private to that class. You can have private public classes in a module that are private to that module only. We can enforce those boundaries by making VM modifications and stuff like that. On the security manager side, we can start moving stuff off from the boot class path that we don't need to, which is a source of security errors in systems like applets and that. If you're running Corba or LDAP on the boot class path, That can be an issue when people do method chaining stuff and all this. If we pull more stuff off there, there's less risks of this code causing an issue. And it has to be approachable. That means that we want it to be easy for developers to use this too. This should not just be for the JDK, but it should also be for you to take advantage of this on top of the JDK, to create your own optimized images, to create your own distributions, but also to build your own modules on top of. So Project Jigsaw is essentially the design and implementation of this module system for the Java platform, but it's also going to apply to the platform and the JDK itself, and you can apply it on top of the JDK. And essentially, I like to think of this as the Ouroboros. Jigsaw is a bit like an Ouroboros. If you know what an Ouroboros is, it's a snake or a dragon that eats its own tail, and it doesn't represent cannibalism. It represents reflexivity, or it represents rebirth. Jigsaw's been through a number of iterations now. You might realize we've been talking about this for a long time. I think this may be about the third iteration. It's rebirth again, and it's coming up even better than before, I think. So this, just to get that idea across, it's like this symbol also is associated with a phoenix, rebirth coming back and recreating itself again. I think that's a nice symbol for how I view Jigsaw at the moment. Not a cannibalistic thing, a rebirth and thing, if you like. So there'll be no pain, no gain, in a sense. We are making changes to the platform. rt.jar, tools.jar. They're going to go away. So is the extension. Who depends on rt.jar and tools.jar? Okay, who of those are IDE developers? They work in the IDEs. Okay, so I'll talk about what we can do with that and how you can use alternatives to do that. But we would like feedback from people on this, whether it's going to cause them problems, it's too much. And we will listen to people and what they say and try and take that on board. The other area is sun.star, star.internal.star. How many people use internal classes in the JDK? This one is more. How many people use unsafe? My favorite class. Not many. I use unsafe. That's not many. That's actually a surprise. I thought I'd see more. These are going to be made much harder to get at. We can't evolve the platform if we can't evolve what goes on underneath the covers. We can't make improvements, can't make performance improvements, can't enforce integrity and stuff like this if we allow access to the internals of what's going on here. So we're going to make this more difficult over time. We are going to provide ways forward to migrate off certain classes like Sunmisk, Unsafe, and that. There are already, say for example, we added base 64 finally from the internal one that's used. Stuff like this, we will replace legitimate use cases with public stuff. So the idea of Sunmisk Unsafe is we will try and replace valid use cases of that with safe but as performant or as near performant as unsafe that we can get going forward. And this is a long-term strategy from 9 through to onwards with Valhalla and Panama projects and stuff like that, like Brian talked about in the keynote. So the status is we have a couple of JEPs. The link's in here on the slides. So the JEP is the way we talk about features in OpenJDK, and you can read about these JEPs here and describe what it is. So we have the JEP 200, which is a modular JDK, which is sort of the umbrella descriptions of what we're going to do. And when we have a couple of JEPs underneath, the modular source code JEP, which is actually done, we restructured the JDK source code layout to be separate in terms of little bits of source. I'll show that in a moment, and that's done. We're working on the modular runtime now, which is a replacement for rt.jar. That's in progress. We have an early access builds of that I encourage you to download and try out. And then we have a JEP that's unnamed at the moment called the JDK module system. This introduces the actual system of how you define your modules and how you deploy your modules and so forth like this. This is to be determined, but we are actually working on this already, and I'll show demos of this. Then beyond that, we have the JSRs. We will have a JSR for the Java Platform Module System, which is associated with the JEP, with the question mark, and that will happen soon. I can't say exactly when, but it's got to happen soon. Hopefully by the end of this year. And then there's the Java SE9 release contents, which will actually have some work to do as well, which I'll explain in a moment. So the demonstrations. So I'm going to talk about the modular source layout with JDK9 dev. These are links to the HG repositories. And talk about the runtime image. You click on image there, you can get a download for the early access builds of that. and with the Jigsaw M2 implementation there in HG2. And I'm going to talk about the module system prototype, which eventually will be available open source for people to access. And there's 3 examples here. I may run out of time, but I'm going to talk about a simple 101 example, and I'm going to talk about modular juice if I get time, and then I'm going to talk about service loaders on steroids using modular juice. So we'll see how far I get. Okay, so the rest of the talk, that's the slides done. So the rest of the talk is in the IDE and terminal, like so. So I've got a little notes.txt script to remind me what to go to, so just forgive me if I copy and paste stuff to remind me of stuff. So what I want to do is just show the modular source layout first. So I've moved into my local copy of Jigsaw M2 repo here. I could HG, just to show you, HG log minus R tip. So that was the last check done in by Alan Bateman. So if we just do an ls on here, what we would have seen was a source, was a source share classes layout. And what we see now is a source and then a name, essentially a module name of the source split up into separate areas. So we see here like the Java base layer here, and underneath here we'll see the share classes directory with all the classes associated with the base, the lower level of essentially the JDK, if you like. And then there's a bunch of native code for Unix, Windows, and so forth like that. So we essentially split all this source out. There's stuff for, say, like Java Desktop as well, same layout like this. So we separated it all out, and we modified the build system so if you made a change to Java Desktop, it wouldn't rebuild Java Base or something like that. So, and that to get to that point has taken quite a number of years to tease apart all the classes in the JDK to have these nice clean boundaries between them. It's taken quite a while to get there, and there's quite a lot of work to get to that point. And that's in JDK 9 today. So I'm going to now show you the actual runtime image layout. So I built Jigsaw M2 myself, and I'm going to go to the actual layout of the image here. Let's just do a find in here. I'll zoom in a moment. And so we have a bin directory that's familiar with Java and so forth like that. So we have a lib directory, and we have a bunch of files in, like dynamic libraries and so forth like that. But we also have a modules directory with some JImage stuff in, which is new. So if I just go up to the top of here, back again, and is there an rt.jar in here? Find. There's no rt.jar in the JDK image anymore. It's not there, doesn't exist. Find minus name. That doesn't exist either. We got rid of it. So where's it all gone? So what I showed you before was, instead, there is stuff here called images, which are proprietary to the runtime here, where all this information is now stored. So we can actually have a quick look at that. Let's just OD it on the head there. So we're ODing an image. Does that look Cafe Dada? How come we can read that? Why is it easy to read from left to right? You want to guess? This is in the native image. This is in native byte format. It's native endian format. That's the reason why you can read this. This is an image particular to the actual architecture system I'm actually running on. So this is different from rt.jar because a jar file is an execution format and a portable format at the same time. If I was going to look at the OD for a class file instead, we would see it in the big endian format. So we see cafe bay b, like so. So that's in the big endian format. It's in a portable format. So I just get the point across here. So this format's quite interesting. This was designed by Jim Lasky of Nashorn fame. If we look in the source file in Hotspot, we can see what it's actually using as an algorithm. Because we know up front all the names of the classes, what we can do is we can create essentially a perfect hash. So we can get a very efficient lookup from the class name to the bytes of the class file. And there's a link here to the algorithm Jim's used, which is a practical minimal perfect hashing method. So this is one performance enhancement we can make because we've changed from rt.jar to a proprietary binary image that we're allowed to update at any time we want to. So we can start doing interesting performance enhancements like this. And we should get some boost in terms of startup time in this because we can look up things faster. We don't have to decompress from the zip file underneath the covers. Okay, we can actually, there's a little tool here that we can actually use, which is list the contents of an image. This tool may or may not exist as part of the standard distribution, but you can actually list inside if you want to. And you can see there should be, you can see all the class files represented, listed out in the image and so forth like that. So that should be there in the Jigsaw M2 distribution. So this is not rt.jar anymore. What do you think is going to happen if I do a get system resource on the path to the class? What URL should it return instead? Have you ever done that? Have you ever looked at the URLs for the class files and stuff like this using get system resource or get resource from a class loader? So let me just show what's going on there. I'm just going to compile something up and I'm going to show a little simple example. Loads up. There we go. I've got a very simple program that's just going to print out where a class is located on where the bytes of the class are located on the system and what class loader actually loads it. So I'm going to show it for this image class I have in a little Maven project. I'm going to show it for class. I'm going to show it for Java util logging logger, Java compiler, the implementation of the compiler, and a natural script engine. I'm going to run that in Java 8 first, just to show you what it outputs. Okay, let's scale it up. So we see the image class. It's loaded from the file system because it's exploded out as a class file. Target class is Oracle image.class. It's loaded in the system class loader, the app class loader. JavaLang class is loaded from rt.jar on Java 8. And it's loaded by the Bootstrap class loader, so its class loader is null. Logger is also loaded from rt.jar. And its Bootstrap class loader is no. Same for Java compiler. But the implementation of Java compiler is actually not present. Anyone guess why that might be the case? So tools.jar, is that what you said? Yeah, it's not there yet. But Nashorn scripting engine is implementation. That's loaded by the extension class loader. So that's located lib.ext Nashorn, like so. .jar. So if I run that with the tools.jar added onto the class path, we should see the Java compiler come into play there, located there. But let's run this using the Jigsaw M2 image instead. Let's look at the top. Well, we see our image is exactly the same, app class loader, system class loader. Now we see something different. JavaLang class, look at this. There's a new URL scheme here underneath the covers. We're no longer talking about rt.jar. We're no longer talking about this. We have a new scheme called JRT, which underneath the covers, it will know which of these J images I showed you before. It will know where it is, and it will know it based on the name of the module, java.base, and then the fully qualified class name underneath, so it knows where to go directly. And that lookup can be very efficient because we know we've done some perfect hashing on all these names of the classes. We see that Java util logging's there too. We see that Java compiler's there, but we notice we actually have more stuff visible now than before. The Java compiler is actually there. The distinction between the JDK and JRE is less now. The JDK contains a whole JRE, but there's no distinction in what's on the class path as was before. And we see that Nashorn's the same. The important thing here to notice is that we're maintaining compatibility with the class loaders. Even though that the extension mechanism has gone like rt.jar and tools.jar, we're maintaining compatibility here of the class loader hierarchy, and that's quite an important thing to do. Okay, so I'm going to move on now and go to the module system prototype that internally we refer to as Jake, which hopefully should be opened up in the near future. I just want to show something. Let's talk a little bit more about the module graph in Jake. So what we generate in Jake at the moment is multiple representations of how we describe those graph of modules I just referred to as names before, like Java Base and Java Desktop. We actually generate an XML file which is referenced in one of the JEPs, which describes the modules in an XML format, like, for example, Java Base here, what packages it exports, and so forth. Let me scroll down. It exports lots of packages, so forth. If we go to, say, like Java Desktop, like so, we can find that. Let's find its definition. We see lots of exports. I can't find it. I'll show you it in a different form. The point is we can represent this module graph in various different ways, and this is one way we're representing it so that people can look at it and understand what it is. I'll show a visual form in a moment. But one of the things I want to get across here is please don't get hung up on the syntax just yet of what I'm going to show for these module descriptions. I read an interesting thing I got from Hacker News recently. Joe Armstrong, the inventor of Erlang, he's actually talking about whether Erlang required a module system or not, and he's wondering if he could create a big global hash map of function names to function definitions and implementations like this. And he was exploring this idea, but he was proposing ideas, and he said, I hardly dare suggest a syntax for this, since I've been following another thread in this forum where syntax discussions seem to encourage much comment. That is so true. We sort of dive on discussions on syntax, and we all comment on each other's syntax, and we miss the point of what we're trying to do, in a sense. So please don't get too hung up on the syntax of what I'm going to show. There's a link there I have on the email. Where's my browser? An interesting strategy, just to sort of segue a little bit, it says you can suggest alternative syntax, but do not comment on other people's suggestions. That's a good way of halting the process. Anyway, here's another representation, which is likely more to be more permanent in Jigsaw. So what we're also doing is we're generating other forms of description. So in the build process of this prototype, we see what we have is something called modulinfo.java. If you've been following Jigsaw a while, this shouldn't be too much of a surprise for you. This is more Java-friendly syntax of describing the Java base module, in a sense. It says what it exports in terms of the types in certain packages. It has a name, java.base, and so forth like this. And it has what we call qualified exports, where it says I export a certain package only to other modules and not. So this allows me to export internal stuff, but only to other types of modules, not to everybody in the whole world. And at the bottom, there's a bunch of what we call service providers, where we say, which essentially is a more declarative description of service loader. So we can say that Java Base uses service provider interfaces, and I want to have where I want to find implementations of, say, asynchronous file channel provider and so forth like that. So we can see another one, say, for Java Desktop. Like so. Here's something I want to point out here is Java Desktop is now requiring modules. Java Base is the bottom module, so it can't require anything. Java Desktop is something that sits on top and requires modules, and it says it requires Java Base, which all modules already require, so it's redundant. But it also requires Java.prefs, which is the preferences API, char sets, and also XML. But it requires a public version of XL, which means I require anything that requires Java.desktop will also implicitly require Java.xml. And one of the reasons is the API, the methods, and the types in the methods may be using types in XML. So it has to re-export those XML types because it depends on those in its public API. So that's another way of representing the module descriptions rather than this uber module.xml. Java-C will actually compile this into a class file format I'll hopefully show later. What the build process does, it takes that source I showed, takes those module infos, and generates something called JMod files, which are, they're not jars in a sense. They're kind of, you can think of them as jars, but containing native code, containing configuration code, and this. So I can, just let me show you unzip Java base. So it contains, it's actually a zip file at the moment, but it might not be. Its format could change. We could have something more optimal as a distribution format. It contains classes. It contains native code. This is actually a JMod that's specific to the Mac format. It contains execution, bin Java. So for this JMod is actually a distribution for the Mac of the most minimal JDK you can define, this module here. So we essentially have a bunch of modules which essentially represent the JDK in modular form, and you can compose these modules together how you want. So if I wanted to create a distribution with Java Desktop, I could create that, and it will work out what Java Desktop depends on, pull all in the dependencies, and create this image just with those in, and not everything else like Corba or RMI. Unfortunately, we can't modularize serialization. If we could, we would, but we're stuck with that for the rest of our lives, I think. Okay, so I can actually run this. So I can actually list the modules in my system using, I don't know if you can see that, run it with Java xlist modules, and I'll get the same modules I showed before in source layout and JMod format, and I can actually cat that using, just to count how many there are there. There's 55 modules listed in the JDK image there. So let's actually show the graph, get a bit more visual on this information. So when we build Jigsaw, we generate a dot file, and then we can convert that to SVG. And I've transitively reduced this dot file to remove some of the edges here. Let's see if I can see that. So at the bottom here, we have the base module. Everything depends on base. I'm just not showing all the edges to base. And then logging depends on base. But then we have some compact profiles which we build up, which aggregate other modules. And at the top, we have the Java SE module. So these nodes in orange represent the Java modules which will be standardized, which are APIs that are standardized by the Java SE release process. And the Java SE9 release process will also standardize this graph of the orange nodes. So that if you look at, say, prefs depends on XML and so forth like that. The bold ones say I'm exporting publicly the APIs that I depend on. And the way the transitive reduction works out, it's actually not showing all the bold ones it should. But the idea here is that you shouldn't, actually let me back up. The blue ones here represent JDK-specific modules that are specific to the Oracle JDK and not part of the standard. So what you should expect is that an orange one could depend on a blue one and re-export to the orange types, but you shouldn't expect it to happen the other way around because you'd be introducing a non-public API in a public module. So for example, the XML-WS module depends on the HTTP server as an internal detail, but it doesn't re-export the HTTP server's types because that would break the boundaries of the system. So that gives you an idea of the whole module graph here and what we have. SE9 will standardize the orange bits, and Oracle will do its own with the JDK bits like this. So it could change, but I don't think it's going to change by a lot. Okay, so let's get more into some demos and move into a simple 101 modular example. Actually, I'm in Jake for module system. I just want to run that image class I ran before to show you the where classes are found and what the class loaders are using, just to make sure everything's the same. So I'm running that class again, and it's exactly the same as Jigsaw M2. The class loader, things are the same and so forth. Even though logger is in a different module, it's not loaded by a different class loader. Same goes for the Java compiler. Nashorn's loaded, still loaded by the extension classes. So the important thing here, even though we might have modules in the system, we're retaining the same class loader mappings as before. In a previous incarnation of Jigsaw, we didn't actually do that. And that was actually, it sort of split the world into two, the class path world and the modular world. And that made it very hard for people to transition their code to the modular world. So now we are actually retaining the compatibility of the class loaders that we had before, and that's much less disruptive when transitioning to modules. So let's go for a simple 101 example. I will build this. Actually, it's built pretty fast, so I don't need to wait. Let's go something really, really basic. So I'm using Ant for my sins at the moment, which is not the best thing to use, but I can't use Maven just yet for this. So I have two essential modules in source form here that I'm going to talk about. One is foo in the foo package in the foo module. It doesn't do anything particularly fancy. It just the main method will just print out what its class loader is, and it has a method called fooify that takes a string and puts foo in there. And at the risk of sounding like a farmyard animal, there's a bar, and a bar, like so. And in the bar module, bar depends on foo. It wants to reuse the foo type in the foo module, and it wants to call foo.main and fooify some information, like so. So I can build that. I can actually run that in the class path today. I just use Java-C to compile it up and run it in the class path, like so. And it should all work as expected. You get the bar loaded with the system class loader and foo, and then foo bar coming out, like so. Now what happens if I run that, but I somehow forget to put foo bar on the class path? What do you think will happen? Will it work? Will it get an exception? One of these strange exceptions coming out. If I get to put that in, I'll get a no class def found error. And it's not very helpful where that error comes from. I get it from where I'm using the class, but it's not really telling me. Like if you've got lots of things on your class path and you get these types of errors, you know, it's pretty hard to resolve. How many people have encountered these types of errors when dealing with their class path? Like, yeah, everybody, blimey. This is horrible. This is class path hell. We must be able to do something better here. Maven helps to a certain extent, because Maven's pretty good at building up the class path at compile time. But it can still be a bit of a mystery about how Maven resolves stuff. I think Maven is a mystery to me, full stop, but that's a separate issue. Okay. So what I'm going to do is I'm going to put module descriptions on these foo module and bar module. And just for the sheer hell of it, just to stress the point of not getting too hung up on the syntax, I'm going to do it in JSON, because I can. So I've got a foo config JSON which says what the module name is and says that I'm exporting the foo package. And I've got a bar config JSON which says the name, exporting bar, and it requires the foo module like this. And what I'm going to do, I'm just going to generate source, modulinfo.java source I showed before, and I'm going to let Java-C compile that. And I've already done that in there. So I have a gen source task where I can generate these module infos. I could go straight to bytecode if I wanted to instead. I don't have to generate this step. The important thing I want to get across here is the information doesn't have to be represented in this form. In Maven, you already have a POM file, you have a name, you have a version, you have dependencies. What it's missing is what types it exports and whether they're exported publicly and so forth like that. Perhaps we could add that information into the Maven POM file so you could modularize using the tools you have or in Gradle or so forth like that. And this modulinfo.java doesn't actually exist in your source code at all. Okay, so I've shown the modules here. So I want to run this with something called a module path. So I have my No, I want to edit that. So I have my jars built, like so, foo and bar. I want to run that in the module path. So at the moment, these command line options could change, but I don't think the concepts will. Our module path is essentially where the jars are. So it's like this. We don't have to specify each module independently. We just specify a directory of where the actual modules exist, but we want to run. And then we specify the module itself. So we want to do bar like so. And now it's running in the module world. No different as it's before, but it's running foo and bar as modules, not essentially types on the class path. So if I remove foo now, and I run the same thing again, instead of getting a class no-def found error, I'll get a bar requires unknown module foo, which is a much clearer error of what's going on here. It's saying, well, you don't have a foo available to you. Perhaps if that error is propagated via a tool, like the IDE in that, or in Maven, it could suggest where foo might be, and so forth like this. You can start, there's a much clearer error of what's actually going on here. Yes, there's a question.
So what would you get if you still had the module, but the module foo would not contain the foo class?
It would be ignored. The question is, what happens if you had a jar file called foo in that build.jars area, but it wasn't a modular jar in a sense, and it would be ignored, that jar file. It has to be a modular jar.
No, but I mean, it's a module, but it just doesn't contain the foo class.
If it doesn't contain the foo class, that's a good question. I have to actually run it to know exactly what it is. I think you will get a no class def found error. What I'm showing here is actually, I'm cheating a little bit because Java C is not yet enabled for module, doesn't yet have full module support in there. If it did, Java C would catch that error at compile time rather than at runtime. And that would help you. There are other things here I'm not getting too much into with versions and stuff like this. If we get this no class def found error in coming up like this in the module, we can actually augment that error saying, well, you tried to load a class of this name and it's not, and I thought it was in this module, but it's not there anymore. You might be able to come up with a better error. It's not going to remove everything like that, but it will certainly help the situation with class path hell, I think. What about split packages? What happens if I modify bar? What happens if I create, say, a package foo in bar and create a foo bar type, like so. And I just build this up. So do you think that will that work in class path mode? Oh, I don't want that. Will that work in class path mode? Probably. Let's try it out. So that works in class path mode, even though you can seal your jars if you want to, but if you don't seal them, it will work. So we've got a split package thing going on here. So if I run that in module mode, I will actually get an error. It will say that foo is already defined in another module. It could be a clearer error. It could tell me where foo is actually defined in the other module, so we can improve the error there. But it will stop you from pulling in types and split packages and so forth like that. Let me just delete that and carry on. Okay, so what about the question of access control? So this gets back to one of the top goals of security we talked about, and integrity of the system. So you may have seen some commented out code here before I hit it. What happens if, say, the foo module uses my favorite class, sunmisk unsafe? Import the packages here. So I want to use unsafe for something. probably for unsafe reasons. And I want to call this method, which uses unsafe here. And notice I'm sort of looking it up through reflection and bypassing the checks to get access to the SunMISC unsafe thing, because we made it difficult to get access to it directly, but you just use reflection to bypass that. And if you're not running a security manager, it will work. So let's just build that. Let's just run it in class path mode first of all. I can run it with Java 8 first, actually, just to show that this actually works in Java 8 as of today. So I'm getting the address, the pointer size of the ops in the VM. It's 64 bits, 8 bytes. So if you run that in class path mode, using a prototype, we actually get a legal access error. We're locking this down even more than before. So even what you could do in Java 8, you can't do in Java 9. We're making it harder to get access to unsafe. How many people are really unhappy with this? Yes, I can see it's going to make some people's job a little harder. There is a way out of this I'll show in a moment. You can run that with module path, and you'll get exactly the same error. So we're locking this down when you're in class path mode and module mode. There is a get out of jail card, in a sense, if you like. There's a magic flag, but we're going to support, at least for Java 9, which allows you to get access to certain classes. That's the magic flag. So if you really need to get access to SunMISC unsafe and keep on trucking, you can essentially say that Java base exports types from SunMISC and get around that. But that is something that's going to go away at a certain point. Once we're satisfied with the main replacements for unsafe and other cases, this will go away. And it works in module mode too. So let's get a bit more into the module infos again and talk about encapsulation, which is kind of an extension of this access control. So if I have a package in foo called internal, you know, this is a common pattern that people do. How many people, when developing their libraries, have an internal package to say, this is stuff you shouldn't use, don't mess around with it. If you do, that's your fault, because I'm going to change it anytime. I've done this too. It's kind of a way of signaling that people shouldn't depend on this stuff. But there's no way of stopping people from depending on this. It's just a naming convention that you use. So if I add a type in there, say foo impl, like that, and say bar wants to depend on that, if I could actually type, like so. I can do this because the IDE is not modular aware at the moment, so I can get away with this. And I can do this because Java C isn't modular aware. It would be much more difficult to actually demo this otherwise. So if I have that and I compile it, taking a while, and I actually run that now, I will get an error, a legal access error. Try to access class internal foo impl from class bar.bar. The error could be improved, telling me which module it was in and so forth like that. But we're locking down, foo has an encapsulated piece of information there. Even though this class is public, it's actually private to the module.
Was it based on the name internal?
No, it's based on something I'm just about to show. So if I want to expose this out to bar, I have to actually edit my configuration and say I not only export all types in the foo package, I export types in the internal package as well. And because bar depends on foo, it will now get access to foo impl. So if I run that, I'll show the module info generated. So if you look at foo's modulinfo.java, you can see it now exports internal as well as foo there. And if we run it, now it works. So that gets across the point of encapsulation and access control in there.
Occurs during runtime, not during compile time?
If I can hear the question correctly, it says it works at runtime but not at compile time.
Yeah.
The only reason is because Java-C hasn't been modified yet. It should catch these errors at compile time. The IDE should work it out too. You know, there's a lot of extra additional work that we need to do going forward. Java-C is sort of lagging behind the runtime aspects in this area. Okay, so that's that demo done, I think. So I've got 16 minutes left to do juice, which probably is a little bit too tight, but at least I can start talking about it. Actually, no. What I'll talk about now is I'll talk about JLink, the runtime image. What we need to do at the moment to get a runtime image in the prototype is create, from those jar files I created, if I just unzip -L, you can see we have a jar file. We have a modulinfo.class, so we compiled in there. Java-C at least knew how to do that. So that's our modular jar. To create an image, to use the tool JLink, the linkage step, I first need to convert those to something called JMod files I showed before. But that's just a temporary step. It's a limitation in our system at the moment. So I have essentially these JMods in there, and I want to install those JMods into a runtime image. I want my foo and the bar and what they depend on and nothing else as my Java runtime image. So what I can use is a tool called JLink here, which allows me to obtain the modules given a module path, which is all those JMods I showed for the JDK. I want to point my module path to say, I want all the JDK modules visible to me or observable to me, and I want the modules foo and bar to be observable to me, and I want to say my entry point is bar. And so it will work out, it will essentially just traverse simply the module graph and pick out all the modules it depends on and nothing else from those two module paths. And then I want to output it out into an image. So we can take that rather large command line there and run that, and that will build me an image. So we can actually find the image here. I have a little mini JDK. We can see there we have the lib, we'll have the lib modules, we have a bin directory with Java. We also have executable commands for the executable modules bar and foo. We have when I converted to JMod, I said I want these modules to be executable. Here's the executable class that I want. So it will generate a little script for you to execute those. So I can actually run foo in the image, like so, or I could run bar, and we get the same information out as so. If we list the modules, so I can run the Java command in that image, and if we list the modules there, we have bar, foo, and Java base, and that's it. We don't have anything else. It's actually quite, comparatively, it's actually quite small if we just use DUK on it. It's about 32 meg in total. And half of that is the hotspot server VM, which if you're in the embedded world, that can be reduced by quite a lot. Now, the interesting thing is, even with this, if we have the linkage stage and optimizations, we could potentially reduce that down even further, because we might not be using some classes in Java base, and we might know statically we don't need these types of stuff. So it might be even possible to get further optimizations when we use ahead of time AOT type stuff and all this. So there's interesting progress forward when using JLink. JLink is a place where you can stuff in a lot of interesting optimizations going forward. So if we run that image class again, as I showed before, we will see, well, the logger isn't present. We don't have the JDK logging module installed. The Java compiler's not there. The Nashorn scripting engine is not there. I haven't installed those modules. Bar and foo do not depend on those modules, and base is the bottom module. So we don't have it in there. I can actually just to sort of strengthen the point I'm making, I can actually run a JLink just to have Java base, and only Java base in base image like so. So I can do du-k builds like so. It's very similar because foo and bar are not very heavy. They're very lightweight. So I can actually bootstrap an image from an existing modular runtime image I already have. And you can start building up your own distributions in the same way. And dare I say it, to be buzzword compliant, you could stick them in Docker and be reactive and all sorts of stuff like that. I had to get that one in. Okay. So I have 11 minutes left. Let me try and at least touch on the topic of Juice, because I think it comes from a use case of trying to modularize an existing popular application. Now I've been told, talking about Juice, I'm not very current and hip. I should really be talking about Dagger, but I did not have time to be hip and update my slides. So I'm talking about Juice 3.0. So the idea was I wanted to take Juice from Maven and experiment with it, see if I could modularize it and build an application on top of it. And with that experience, see how well the Jigsaw tooling is working, see how we could think about how it might integrate with Maven and existing tools like this and so forth. So let me show you the module graph of Juice and how I actually came about or working out what it is. So here's the module graph of Juice. The blue stuff is the juicy stuff. The orange stuff is the JDK stuff. So we see the desktop, we see Juice depending on logging. Juice depends on desktop. What is going on? Why is Juice depending on desktop? I will show that in a moment. Is a real big annoyance. But Juice depends on AOP Alliance, Juice depends on JavaX Inject, and then there's a module, Juice Multibindings, which is extensions to Juice, which depends on Juice itself. It's not that complicated. The way I determined the sort of blue bits was I went and basically created a simple POM, and I did MVN dependency tree on that POM. Like so, and you'll get the graph out showing the relationships between multi-bindings, Juice, Java Inject, and AOP Alliance. That gets you so far. It tells you the relationships that are going on. It doesn't tell you what packages in Juice are public or should be public and so forth like that. It doesn't give you those types of places, but it gets you started. And there's a tool called JDEPS, which is actually also in Java 8, which has been enhanced, which shows you dependencies between jar files and packages and so forth like that. So I can run this, and I basically downloaded the Juice jars using a Maven Ant task to get all the AOP Alliance, Inject, Juice multibindings. And I can run a tool called JDEPS, and that will tell me more information about what Juice and its modules depend on. And let me put that into Vi so I can scroll a little bit. So up the top, actually, it's not showing me what I want to show. Okay, now let me put it into Vi. I thought I was going to get something on the top, but no, actually, let's go down to, here we go. Sorry, I was just missing it. The order wasn't what I expected it. So Juice depends on the AOP Alliance. Juice depends on Juice. That seems to be a bug. Juice depends on Java Base, Java Desktop, Java Logging. And then it goes in and tells you the types in the packages and what modules they depend on. So Java Lang is base and so forth. So Juice is using a type in the package of com Google Inject is depending on a type in Java Lang. So that's what essentially that means. So we get down, we can see Juice base, nothing particularly, logging, it's using the logging API in there. Then we see some internal stuff. So it's Juice is using the internal name to say, this is stuff that you should not be depending on, but I can't stop you, please be good. Then it's saying what it's doing is actually rebundling cglib. And unfortunately, cglib is using types in Java Beans, which depends on the desktop module. We cannot split out Java Beans from the desktop. without breaking things too much, unfortunately. That's the state of affairs we are at the moment. It's an unfortunate one, but that's where we are. We can actually see the code in CGlib, which is actually doing, it's using the Beans Introspector API. It's really unfortunate to have to pull in desktop. I don't know what to do there at the moment. Maybe we should upgrade CGlib not to use Beans or something, or maybe we can split CGlib into two, or something like that. But I'm not sure that Juice actually requires Beans usage. It'd be interesting to experiment with that. I don't know if this is a permanent situation, but we have tried pretty hard to break this dependency, and it's proving quite difficult at the moment. So in a combination of JDEPs and Maven, I can work out what this graph is, and I can actually, I find my juice. What I've done is I've handcrafted modulinfo.javas for each of these, for each of the jar files I have. And I created the Juice one, and I worked out that Juice requires JavaX inject and AP Alliance, and I'm exporting them publicly. It requires Java logging internally, and alas, it requires Java Desktop. And it exports these public APIs, and I've worked that out from saying, well, any non-internal package I can export out. I also had to work out that Juice multi-bindings depends on internal stuff in Juice. So I have to export packages, internal packages, but only to Juice multi-bindings. I don't want to export them out to anybody that requires Juice. So that's a similar thing we're doing in the JDK as well. And to work out that, I had to use JDEPs, not just Maven. I think a combination of Maven and JDEPs together could actually, you could write a pretty nifty Maven tool to work out what's going on underneath internally and almost automatically generate these types of, this type of information on the fly. The question is, can we do this in Maven? Yes?
I'm not really familiar with JDEPs, but you also got dependency analyze, which does class analysis.
Dependency analyze, is that a Maven plugin? Yes, you could use that too, I think. JDEPs has a bit more knowledge about what's going on in the JDK and the modules in that. I think you could possibly enhance that plugin to do exactly the same type of thing.
You are already using dependency tree, which is just another goal with the same.
Yeah. Yeah. Okay, so the answer to that was there's a goal associated with the Maven dependency plugin that allows you to analyze class dependencies. So Maven has a name already. It knows what it depends on. There's just no way of expressing this in the POM yet. Maybe we could do that. I'd be very interesting to hear from the Maven community about their thoughts on these matters. Likewise, there's no way of expressing this in Maven just yet. So I've done this for all of the modules here, and what I do is I compile those jar files using Java-C, and then I stuff those compiled modulinfo.javas into the existing Juice stuff, and I create modular jars that way. And I have 3 minutes left, so I think I'm going to have to stop there, and if there's 1 or 2 questions, I can take them very, very quickly. Yes? So I can't see very well. The lights are bright. There's a gentleman over there with his hand up at the back. There. No, you, sir. Yes.
So with the module system, would it be possible in theory to mix and match modules from different JDK implementations?
You mean the JMods? No. I don't think it's going to be. They're going to be specific to the Java distribution. The particular implementation, those JMods. For modular jars, of course, but for the JMods, they're going to be particular to the distribution. One quick last question.
Is the output of JLink platform specific?
Yes. Actually, it doesn't have to be, because JLink could be the place where you create jar files too. It could be the place where you translate code into other code. So we could actually use it as an alternative to jar going forward. So it could actually transform portable code into portable code, as well as portable code into native specific code. Okay, I think I'm going to have to stop there. Okay, thank you very much.